So this is the offset inertial wheel stripped down. There's no reason for this wheel to do any work. You'd have to put some energy into it, right? To get some work out of it. Alright, so let's change the equation. This is just a steel spike, 3 pounds. So I'm going to place this up here. So all we need here is a stable weight. A 3-pound weight here on a bicycle wheel, free spinning. If we put a weight at the top, it falls to the left or it falls to the right. So let's call that top dead center. So there's a mark sitting right back here. I'm not going to move the camera. But this mark signifies top dead center. So I'm just going to drop the wheel. There it goes. Alright. And stop. So right here, we have a distance from the white mark to top dead center where it would again drop due to its own weight. And again come to the same spot. So this is a 90% rotation. Gravity is pulling to here, and then inertia is carrying it back up to the top with the perfect arrangement of weights. It could weigh 10 pounds, it could weigh 100 pounds, it could weigh 100,000 pounds. Distributed appropriately, it's still going to do a 90% plus rotation. So what I found was that actually the spot to add energy into the cycle to get it over the top into a high speed rotation was to add energy at the point of least resistance when the weight is traveling back through the cycle right between gravity and inertia, right about here. So we see that the weight traveling on its own accord can do 90% of the cycle, and if you distribute it properly, you can get up to 98, 99%. So obviously this requires work. I'm doing work here with my hand. This is what I call the agitator motor. The agitator motor in the video sits up here, right there. I just wanted the wheel to touch the agitator at a very small part of its rotation so that they're not touching all the time. I want the least amount of input for the most amount of output. So, and when this starts rocking, even though it has tensioners, when it starts going really, really fast, well, I'll show you. You just speed it up and you can see it wants to rock back and forth, right? So I put tensioners on it, and those tensioners allow it to basically come just up here enough. 3 to 5% of the rotation touches right there, just for a second. And that was running 4 of these constant. So these were applied to the wheel constant. It sat right there, and I don't lower them down to the wheel until the wheel's at a high speed. So it breaks that initial resistance that these would typically have. So I think hopefully this will help to explain the basic premise of what it is that I'm presenting, what I mean by offset, offset inertial. So now you see there's an offset weight. The weight offsets the wheel. And if we utilize that offset characteristic with gravity, then inertia, we get 90% of the rotation. We add just a touch to that, and we get over unity. Now I say over unity because from what my tests have shown, the amount that we need here is significantly less than the amount that comes out of this wheel at full speed. It's amazing.